Have you ever typed a question into an AI like ChatGPT and just stopped and wondered, what is actually happening inside its digital brain right now? How does it get from my words to a perfectly human-like answer? Well, today we're going to pull back the curtain and demystify the magic behind large language models.
And that's really the core mystery we're going to solve. We are literally going to follow a single sentence on its journey through the AI's mind, from the second we type it to the moment the AI predicts what comes next.
But, before we dive deep inside, we've got to start with the basics. So our first stop on this tour is just figuring out what an LLM actually is.
Okay, so what is a large language model, or LLM? Well, at its core, it's an AI that's been specifically built to get a handle on our language. We're talking about the powerhouses you already know, like ChatGPT, Claude, Gemini. They're all LLMs. And what they can do, it's pretty amazing. They can chew through a massive report and give you the highlights, help you write that tricky email, translate languages on the fly, and even write computer code. They're these incredibly powerful, versatile tools.
So that's the what. We know what they can do. But the big question, the one we're here for, is how. How on earth does a machine make sense of something as tricky and full of nuance as human language? It's time to open up that black box. All right, our journey begins. The very first stop for any sentence we type is something I like to call the translation desk. This is where our language gets prepped for the machine.
And here's the first and maybe most important rule you gotta understand. AI doesn't get words, not like we do. It speaks one language and one language only: math, numbers. So every single word we use has to be translated.
The part of the AI that does this is called a tokenizer. It grabs our sentence, say, "Hello, I am GPT," and first it breaks it down into these little pieces called tokens. Then, and this is the key part, it swaps each token for a unique number. That final sequence of numbers, that's what the AI actually reads. Okay, so now we have a string of numbers. But what's next? You might be thinking they're just, random ID tags, but there's so much more than that. The AI now has to figure out what these numbers actually mean, and it does that on a sort of giant map of meaning. This is where our process called embedding comes in, and it operates on one golden rule. The AI takes each number and literally places it on this huge multi-dimensional map. And the whole point is this: words with similar meanings get placed close together, like neighbors, while words with totally different meanings are put far, far apart. Think about it like this. On this crazy map, the word dog is going to be super close to cat, right? Because they're both furry pets. But where would dog be compared to, say, airplane? Miles apart. It's this spatial relationship, this whole geometry of meaning, that lets the AI start to understand context.
All right, so our sentence has been turned into numbers, and those numbers have been placed on a map of meaning. Now it's time for the main event. Our sentence is heading into the brain of the operation, what we call the transformer. This is where the real thinking happens. The coolest way to picture what's happening in here is to think of a spotlight. As the AI reads our numbers, it's constantly shining the spotlight around. This spotlight is a mechanism called attention, and its job is to highlight which other words are most important for understanding the meaning of any single word.
Let's make this real. Check out this sentence and see how that spotlight would work.
So if the AI is trying to understand the word 8, where should it shine that spotlight? On school? Not very helpful. On Chalesu? Yeah, a little. He's the one doing the eating. But what about Apple? Bingo! The AI knows that 8 and Apple are super connected, so it gives a massive amount of attention there. This is how it figures out those deep relationships in our sentences. Okay, after all that incredible, complex work of understanding context and meaning, we've reached the final step. This is the moment of truth, the climax of our journey. The LLM is finally ready to make a prediction. So imagine we've given the AI this prompt. The weather today is so. It's done all its homework, processed all the context, and now it has to figure out what single word comes next. Now, here's the thing. The AI doesn't know the answer like we do. Instead, it looks at every single word it knows, and we're talking thousands upon thousands of them, and it calculates a probability score for each one. So it might think, there's an 82% chance the next word is good, maybe a 12% chance it's cold, a 6% chance it's cloudy, and so on. Then it just picks the one with the highest score. Whew! Okay, that was a lot, I know. So let's take a step back and look at the big picture.
Let's recap that entire journey from start to finish.
And here it is, the whole process in one go. You type in a sentence. The tokenizer chops it up and turns it into numbers. The embedding layer puts those numbers on its meaning map. The transformer blocks figure out all the context, and finally, the output layer predicts the next word to create a new sentence. See, when you break it down, it's not so scary, right? And this little summary here is a perfect way to lock it all in. Think of it as the AI's toolkit. The tokenizer, that's your language translator. The embedding layer, it's the word map. Attention is that powerful spotlight. The transformer is the main thinking circuit. And the output layer, well, that's the mouth that speaks the answer.
So, when it all comes down to it, what's the big takeaway? If you remember one thing, let it be this. An LLM isn't magic. It's a giant, complex, but totally logical language brain. It's a system that has learned to see our world as numbers, to think using maps of meaning, and to speak by calculating the odds. The real question is, what do you think it's going to learn to do next?